Suppose that the lifespan in years of the central processing unit of a certain model of computer is given by the probability density function, or PDF, P of t equals 0.1 e to the negative 0.1 t. What is the probability that the CPU will last at least 5 years? So these probability questions, this is the only applications of integrals topic that you don't have to break down into slicing before you start. You can just use a formula from your textbook or your notes. So we're just going to integrate over the time period that we're interested in the PDF function. So at least 5 years, that's 5 years or more. So that means 5 years to infinity years. What's the probability that the CPU will last between 5 years and infinity years? So we just integrate the PDF function 0.1 e to the negative 0.1 t from 5 to infinity dt. Okay, so the antiderivative of e to some stuff is e to that stuff. You can write out a formal u substitution if you want. I'm not going to do that. So I'm going to say the antiderivative is e to the negative 0.1 t. The derivative of that, the chain rule would cause a 0.1 to be in front, a negative 0.1 to be in front. So I'm just going to put a negative, and that will make the negatives cancel and give me the 0.1 that's right here. All right, so that's good enough. This is from 5 to infinity. That's some poor notation, so I'm going to rewrite that as negative e to the negative 0.1 t from 5 to b, and take the limit as b goes to infinity. Okay, so first we plug in a b, the limit as b goes to infinity of negative e to the negative 0.1 b, and then I plug in a 5 minus negative e to the negative 0.5, because 0.1 times 5 is 0.5. And so as b goes to infinity, this goes to 0. And this comes out to approximately, well, it comes out to exactly e to the negative 0.5, which is approximately 0.61, or 61% probability that the processing unit will last at least 5 years. So for part B, we do exactly the same setup, except at least 10 years is 10 years or more. So I integrate from 10 to infinity. 0.1 e to the negative 0.1 t. I won't write out all of the steps of doing the antiderivative and evaluating this. They're the same as the previous. I'll just tell you that this comes out to approximately 0.37, or a 37% probability that the CPU will last at least 10 years. And then if I want to know the probability that it lasts between 5 and 10 years, I'm going to integrate from 5 to 10. And I'm not going to do out all the calculations to figuring this out. Just tell you it comes out to approximately 0.37. Oops, sorry, I was looking at the wrong thing. Comes out to approximately 0.24.